is measurement of. They are actually profiled in addition to triglyceride and total cholesterol. But today just we measure these two. You know the importance of the lipid measurement, the kind of lipoprotein, and because right now I explained them, we don't need all of them. Just how we are going to measure LDL. The first or for measurement of LDL, you know, we have a different kit for measurement of different factors, different protein or actually lipid or amino acid in our body. We have to use a specific kit for a specific factors. For LDL, we have to use LDL kit. This kit contains some material, some buffers, enzyme, and that. Sometimes we know about the enzyme and buffer. Most of the time we don't know because they made by a company and they don't want to release their data. Just you actually can use them as their instruction, but you don't know what's happening here. But what is happening real in the LDL and HDL measurement? We have a reagent number 1. In the next slide, I will talk about the reagent number 1. It's contained what? LDL plus reagent number 1 is protected. Here, just protect LDL particle. And then the HDL, VLDL, and chylomicron, because as you know, they also contain cholesterol. For the first part, we should disrupt this and release their cholesterol content. And just LDL is remain. We have a two enzyme, cholesterol esterase and cholesterol oxidase. After destruction of this particle, we destroy their cholesterol content and it's become cholesterol and H2O2. Okay? This is the first point. And then this H2O2 by catalase convert to the H2O. So the all cholesterol content of HDL, VLDL, and chylomicron is destroyed. What remains for us? LDL cholesterol. In the second part, this protected LDL, we will add reagent number 2.
Removes.
And reagent number 2 destroy the LDL particle, release the cholesterol. This cholesterol, again by cholesterol esterase and cholesterol oxidase, produce cholesterol and H2O2. This H2O2 by this compound, amino antipyrin and DAOS, by peroxidase enzyme, it produces a compound which is blue color, blue complex. Okay? And by spectrophotometry, by measuring the intensity of color, we can report the concentration of LDL against a standard cholesterol concentration. So we need a standard, we need our sample. Again, like spectrophotometry, also we have a black. So what they are, the reagent number 1 contain this component, cholesterol oxidase, cholesterol esterase, and these actually catalase and buffers. Reagent number 2 again contain Brooks buffer, amino antipyrin, peroxidase, and sodium acid, and the pH is there. What you should do is that you should have a 3Q. 1 for a standard, 1 for blank, 1 for test, or unknown sample, or your serum. They will give you a serum. Then what you are going to do? In this tree, in the standard, just you will add the standard solution. We will know the concentration of a standard solution. And in blank, we just add 10 microliter of the distilled water. And in test tube, we will add the 10 microliter of serum. We just measure lipid profile in a serum, not in whole blood, not in plasma, just in serum we measure. So first of all, you should, after taking blood, you should separate serum. What they did, and serum is ready for you. So in all of these 3Q, you will add 1,000 microliter or 1 milliliters 1 ml of reagent number 1.
How will we add 10 microliters of water then? Because the pipettes in the lab are like 2 millimeters.
No,
milliliters.
We have a specific. Let's go to. No, we have a specific sampler for 1 microliters. We have a specific sampler for 0.1 microliters also. I don't know they have, but they should have. We will check that together, don't worry. We can take a small, tiny of volume. When we are going to do molecular experiment, maybe 0.1 microliter we will add. So, after adding this to treat you, we incubate at 37 degrees for 5 minutes. If there was a water bath, we can increase the time of incubation to 10 minutes in room temperature. Doesn't matter. 5 minutes in 37 or 10 minutes in room temperature. Then we will read the first absorbance at where is the 600 nanometers. So we will read the standard, blank, and test. The blank is equal to 0, just for setting the 0, the standard and sample, isn't it? Then after 10 minutes, we will add the reagent number 250 microliters to each one. Okay? Then again, 5 minutes in 37 or 10 minutes in room temperature. And again, measure the absorbance. So we have 2 absorbance. Absorbance number 2, number 1. You have to calculate the delta absorbance.
The total minus the first one.
Delta OD of test, delta OD of this one. What does that mean? It means that
Change.
OD number 2 minus OD number 1.
What about the blank?
Blank is just using for blank, setting the machine on the 0, just that. OD 2 minus OD 1. Otherwise, 1. Then, after calculation, the delta OD of sample, delta OD of standard, you have to multiply the concentration standard. Multiply by concentration of standard. The concentration of standard is 101 milligram per deciliter. So the final result here, you should record the LDL concentration, LDL cholesterol concentration in milligram per deciliter. You should write the unit, the amount, the LDL cholesterol concentration. Is the first experiment. Then, the second is related to measurement of HDL. It's similar to the LDL, but here by buffer number 1, we protect HDL. We destroy all of the other kind of lipoprotein, and then we will measure the HDL. So the reaction is like that. LDL, VLDL, chylomicron by detergent, they will destroy and produce H2O2, convert to H2O, is finished. Then the HDL, which protected by cholesterol oxidase, produce H2O2, and this H2O2 by peroxidase produce a blue color complex, and we will measure it by this system. Again, like that, we have a 10 microliters of each of the standard blank and test, 1,000 of actually reagent number 1, and 200 microliter of reagent number 2. Here again, we have incubation 5 minutes or 10 minutes in room temperature. 5 minutes or 10 minutes in room temperature. Again, calculate the ODL test, ODL standard, multiply by HDL concentration, which HDL concentration is
45.
45. So you should have a report HDL cholesterol concentration in milligram of deciliter.
What does the 600 nanometer for reagent 1?
Instead of is actually setting of the spectrophotometry. It should be set on the 600 nanometers. Maybe for HDL they use another kit. I have to check it. After that I let you know. When we actually went to the lab, I will check the kit. Because any kit has a specific instruction and maybe wavelengths. But all of them somehow are similar, and I hope they use this instruction also. So, we have LDL cholesterol concentration, we have HDL cholesterol concentration. The next report, you will report the
LDL.
LDL to HDL ratio. What is that? It's for determination of risk of heart disease. How we can interpret that? If LDL to HDL ratio was less than 3, is optimal. Between 3 and 5 is a borderline, and more than 5 has the highest risk of atherosclerosis. So all the time, for your patient, you have to calculate this LDL to HDL ratio. For example, if LDL concentration is 104 and HDL is a 4, for example, 45. What is the ratio?
2.
Less than 3. 2 point, for example, so it's good. Less than 3 is good. So they are a good value. But if your cholesterol concentration is LDL is 160 and the HDL is a 40,
It is 4.
so it's a borderline. If it's more than 200 and for example 210 and it's 40 again,
It's more than 5.
it's more than 5. It means it's
At risk.
has a high risk for atherosclerosis. So I hope it was clear completely, and you don't ask me a lot of questions during the lab because I want to rest. And you should do your experiment by yourself. So the first group, I think you are not too much, and maybe in one group also we can manage the classes.